Hello everyone, welcome back to this channel. Today we are going to discuss some MCQs from central limit theorem. Okay, before that, just let me tell you the definition once. What is central limit theorem? Central limit theorem states that the distribution of the sample means will approximate a normal distribution regardless of the shape of the population distribution as the sample size becomes large enough. That means whatever your population distribution is, let's say this is population and you don't know what is the distribution of this population. That means you don't know whether it is continuous, normal, discrete continuous, uniform continuous, Poisson, you don't know simply. But this theorem states that once you take a sample of large size, it will behave like a normal distribution. Clear? And the large size generally means the sample size greater than or equal to 30. Okay, let me tell you once again. Whatever the population distribution is, once you take a sample of large size, then it will behave like a normal distribution. Okay, now let's solve the question. What does the central limit theorem state about the distribution of sample means? About sample means. Sample means are always normally distributed. No, if the size is not large enough, then it may not be normal, right? It may follow its population distribution. Once it becomes large size, then only it behaves like a normal distribution. So this is not right. Sample means approach a normal distribution as the sample size increases, regardless of population distribution. That is the definition. Okay. Sample means follow the same distribution as the population for smaller size, not for larger size. Sample means are only normal if the population is normal. No, that is not true. But if it is normal, it will also become normal. But the only word is wrong here. Okay. Second question. What is the minimum sample size for the theorem to apply? I have already said greater than equal to 30. Okay, large sample size generally considered like this. If the sample size is greater than or equal to 30, that means it is a larger size and it will follow the normal distribution. Third one, according to the theorem, what happens to the standard error as sample size increases? Error will become lesser, so it will decrease. Okay. Now, if a population has mean equal to 50, standard deviation equal to 12, what is the standard error? See, the formula for standard error is sigma by root over of n. Standard deviation here is 12 divided by n is the sample size, so root over of 36. So 12 divided by 6 equals to 2. Okay. Next question. The central limit theorem applies to only normally distributed. No, population distribution is unknown. Only population with finite variations. Most populations with finite mean and variance exactly. A population should have finite mean and variance. Large population? No, not required. The shape of sampling distribution of sample means depends on what? Only on the population distribution. Only the sample size. Both the population distribution and the sample size. Exactly, both. Sample size also matters and population distribution also considered. Okay. If the population distribution is, let's say, uniform continuous and you take a small size, then what will be the population distribution of sample? Uniform continuous. So the sample size will follow its population distribution if the sample size is smaller. That's why it is dependent on both. For a highly skewed, generally it is considered that if this is highly skewed, like this much skewed, for that you will take n greater than equal to 50. N is the sample size. Okay, now the next one. The central limit theorem is important because it makes all the distributions normal. For that you have to take greater sample size. Allow statistical inference even when population distribution is unknown. That is true. That is the main thing, that we don't know the population distribution, but I know that my sampling distribution is normally distributed if I have larger sample size. Eliminate sampling error? No, that is not possible. Reduces population variance? No, that is also not topic. Okay, so we have discussed all the questions from central limit theorem. I hope the concept is completely clear to you. Okay, so meet in our next class. Till then, bye. Happy learning.